Welcome to a GCBASIC new feature video. This is January 2026, and I'm just going to take you through a new feature that's been added at a particular build. It's important that you understand this. I'll be doing a couple more of these new features videos over the next few days. So GCBASIC is an open source compiler for PICs, AVRs, and LGTs, supports over 1400 microcontrollers with common code, which means that you can compile a piece of code for one chip and it will work on another. Great. So what's this new functionality? At change 1543 or build 1543. So if you've got less than that, this doesn't work. We now support assigning initial values in the dimension statement, a bit like other languages, a bit like C. I was doing some very heavy coding in November, December timeframe, and I got a bit tired, and I thought, why don't I just implement it? And then Angel finished it off. So this bit now supports efficient initialization of variables like bits, arrays, and data types, words, longs and singles, and strings at declaration time. So you dimension it, and then you can assign it at the same time. If you want to see this code, it's change 1543 in the test solutions folder. So let's go and have a look at the code inside of an editor. Here we go, the IDE. I'll take it to the top. It's a GCBASIC program. That actually is just a demonstration so that you can see it. Okay, let's walk it. That's the chip type. Doesn't really matter what the chip is. I'm not interested. Now, what you can do is this. I'll zoom in a lot so you can see it. You can say things like this. mybit, dimension mybit as a byte, as a bit, and assign it equals 1. Historically, you'd had to go dim mybit as bit, new line, mybit equals 1. You can now do that initial assignment, set it to true right from the outset. You can do the same for bits that are aliased. You can do it the same for implicit bytes. You can do it for a byte definition. You can do it at a particular location in RAM. You can do the same for integers, longs and singles, words and strings. Initially, and confusingly, you can always do it for arrays, but you can still do it. Function key F6. Let's have a look. If we look at the assembly, then we can get a better idea what it's actually doing. Here we go. Look. Let me just. There's a variable called myVar3. It was actually put in memory location 33, and we can see that evidenced in the assembly report. If we go to myVar3, says here dimension myVar3 as a byte at location 33. Let me just bring that into view. Dimension myVar as a byte at location 33. We saw that and assigned 20 to it. So it's created the variable type, and then it said in here, move the literal value of 20 into the W register and then move it into that memory location. It's doing it. It makes it easier. You should be able now to dimension your variables and not forget what the initial value should be, because it is an incorrect assumption to assume it's 0. If we look at an integer, just to see an example, dimension an integer, that's minus 1000. It's defined two variables at two RAM locations for that variable at some location in memory, because it's not important, it's fully managed, and it's put the literal 24 into the lower byte and 252 into the high byte. We could have a look at that we could go and look at that in detail, but we don't need to, and it's done the same for a location 34. So what have we got? We can define variables, we can define strings, etc., etc. It just makes your coding a lot easier. So you can go in, you can get my word as 1000 and assign it at one go. a new feature, a great step forward in build 1543, soon to be released. Enjoy.